All right, guys, so welcome to our first Leetcode Friday. My name is Jorge. I am a sort of senior. Like we talked about at the general interest meeting, I'm a second degree student. I was originally a teacher, and now I am trying to become a software engineer. So what we're going to be doing today in Leetcode Fridays is this is going to be sort of an introductory course for you guys. Lots of you don't know what Leetcode is because you don't really learn about that in school. Uh, but some of you want to get internships. And if you want to get internships, you have to know what Leetcode is. So just this will be a quick just summary. Leetcode is a website that gives you different problems to solve, specifically based on data structures and algorithms. A data structure is something like, an array, which you've probably learned in like week 2 of CS 111. And algorithms could be something like using a for loop to go through that array. So if you've taken CS 111 at this point, there are some Leetcodes that you can do. For example, like if you just scroll down, like there's different difficulties from easy to hard. So if I wanted to add, like, I don't know, find something interesting, I can just click on this. And like usually they're pretty easy solutions. It's easy problems. But for today, we're going to go through a couple really easy ones. So first things first, I want to give you guys a quick primer on some terminology that we're going to be using. So I'm going to share my screen from my iPad so I can kind of draw things out a little bit better. All right, so when we're solving problems on Leetcode, we're going to be doing some different terms. So the most important thing that you guys need to know, which you kind of learned about in CS 220, but that's a very formal definition that kind of makes no sense, is something called big O notation. So if you've seen things like this, right? This is big O notation. What this means is telling you the runtime of an algorithm that you're going to be doing. Don't worry too much about what this means for now, but just know that, for example, if we have, for example, an array of like 1, 2, 3, 4, 5, right? And we're going through this array. If we have to go through this array completely and read every single number in this array, say we have n numbers in this array, that would be O of n, right? If we are doing something where we split it in half and then we split the problem in half, we split the problem in half like in binary search, that's log n. You're going to kind of get the general idea as we go on, but for now, just know that big O is talking about the runtime efficiency or the space efficiency, which will make more sense as we actually solve problems. But we're going to be seeing a lot of this. For now, just know that it exists and know that this is talking about efficiency. And if you've seen like a graph of different runtimes, you might remember something like, the factorial is very, very inefficient. Then you might hear something like n squared, this is just a math function, which is kind of exponential. Then you have, oopsie, yeah, I'm gonna use this iPad still. There we go. You got this. You got n log n. This, again, my drawing is really bad, but you're gonna see something like this. Pretty much the smaller the function, the more efficient it is. Our goal is to become more efficient. For now, don't worry too much about it. I'm going to show you examples. All right. With that being said about Big O, let's get started on our first problem. We're going to go from there. So the first problem that we're going to be doing is going to be, let me stop sharing. Smallest even multiple. Let me delete my answer. All right. So this is Leetcode. This is going to be where you're going to answer like different little tricky questions. They're kind of like brain puzzles, brain teasers. And your goal is to submit a solution that works, that is fairly efficient. So here is the first question. Given a positive integer n, return the smallest positive integer that is a multiple of both 2 and n. Here's an example. So first you're going to read these questions, then you're going to read the examples. For example, if your integer is 5, and your output is 10. Reason why is the smallest multiple between 5 and 2 is 10. So that would be something like 5 times 2 is 10. And over here, n equals 6, the output is 6, because the smallest multiple of 6 is both 2 and 6, because 2 times 3 is 6. 2 fits into the number 6 evenly. Pretty much what this question is asking you is this an even or an odd number? So how do we find out if something is even or odd? Does anyone here know based on what you've learned in CS 111?
Mod 2.
Mod 2, thank you, whoever answered. So I'm going to go back to my iPad. So pretty much if something is even or odd, how do we find this, right? Someone mentioned mod. So the way that mod comes up, I'm sure this is mostly a review, right? Like, is 3 odd? If you divide 3 divided by 2, right? You're going to get 1, and you're going to get a remainder of 1. So that remainder is the same thing. So that remainder is the modulo. So 3 mod 2 equals 1. Mod is giving you a remainder. So if the remainder mod of mod 2 equals 1, that's odd, right? So how do we know something is even then? If the remainder of an odd number is 1, what should an even number be? Like 4 divided by 2. What's the remainder for that? Come on, this is first grade math. 0, exactly. So if remainder of something mod 2 equals 0, then that's even. Great. So now we know about how to use modulo. So this is a very, very simple question. It's just asking if you know how to use modulo. So over here in smallest even multiple, let's just do that. Let's just return. We don't even have to do anything. Return. Return. What did I write? Right. So if a number is odd, sorry, an even, right? We would just return that. So for example, we have 4. All right. Is that even? Yes. It fits in 2. So we can say return n, which is a number, if n mod 2 is equal to 0. Does that make sense? We're saying we're returning that number if it's even, because if it's even, it's already a multiple of 2. Else, you can just return, what was it? 2 times n, I think it was. Because if it's not a multiple of 2, say if we have 5, right? So say we have the number 5. Is this fitting in 2? No, it's not. But what about 5 times 2? That's 10. And does 10 fit in 2? Yes. Therefore, 10 is a least common multiple of 5. Does that all make sense? This is just basic math. Let's see if this works. Yep, this works. So once you come up with your algorithm or your solution, you just click run, and then you can click submit if it's accepted. And here we go. We're apparently so efficient, we beat 97% of users with Python 3. So now here's a question that we talked about big O before, right? How many operations am I doing to solve this problem? Like, think about this. Is it like linear? Are we going through an array? What are we doing in this? Does anyone know? So since y'all are kind of quiet today, right now we're just doing one thing. We're just returning something. We're returning n if it's even, or else 2 times n. We're not really doing anything. So technically this would be big O of 1, which means it's constant. It doesn't matter if you have like if n equals 1,000 billion whatever. You're doing the same amount of operations. So that's just a constant time thing. So does anyone have any questions on the solution for smallest even multiple? Yeah? All right. Now we're going to move on to the actual fun question. So two-sum is the first question on Leetcode. It's a very, very, very interesting problem because it has so many different solutions. Two-sum 2 especially, I have 3 different solutions that that really show you the difference of
Corey,
time efficiency. Yeah?
Corey, for the first problem, I have a C++ solution. I'm gonna post it on the Leetcode. It's a more
Oh, sure.
friendly solution. I'm gonna just
Yeah,
post
if
it
you
on the
want,
Leetcode for everyone who knows C++, who wanna check
sure,
it.
we
It's
can do C++.
different. Yeah.
Yeah,
No, I already did
okay.
it, so you don't have to do it. I'll just post it on Leetcode so people can just check it out.
So yeah,
The Leetcode chat. Post a screenshot.
sure.
Yeah,
Yeah,
it's
pretty
C++.
much. I'm going to be using Python for lots of these LeetCode questions just because I'll just show you right now. Like this is C++, right? We're going to return n semicolon C++, else return 2 times n. This should be the same thing, right? Yeah, so the reason why we're using Python is look how much code we're writing and look how many curly braces we're using. We use 1, 2, 3, 4, 5, 6, 7, 8 lines of code for the same exact thing that you could do in Python, which is literally, whoops, which is literally one line of code. You could also just do, if in case you didn't want to be Pythonic, you could also just say, again, if n mod 2 equals 0, return n, else return 2 times n. Right? Same thing. All we're
Can
doing
you
is it.
view? Oh, go ahead. Go ahead.
Sorry, what's your question?
I was gonna say, can you view the lead code to just see my solution? And it's a different solution, so and it's pretty self-explanatory.
Yeah, sure.
Um, you can explain it to them as well. It beats, for some reason it beats 100%, even though it looks worse.
So you wrote int one. Do you want to explain? Okay, so this, I don't know why it would be faster because, um,
I'm not sure either. It
yeah,
shouldn't be,
because
but it
you
is.
are doing more stuff than just returning something. See, this also
Yeah.
beats 100%. So I think it's just because C++ compiles really fast. So
Yeah.
you don't want to,
Yeah.
yeah. So it's not really a big deal. Don't
Mine,
worry about that.
yeah, but mine, because some of the 111 freshmen don't are not sure about returns and stuff like that.
Mhm.
Um, so this might make a bit more sense to them. That's why I wrote it that way.
If I, while true, if I mod 2 equals 0, and I mod n. Can you explain that? I'm kind of confused actually.
I believe the question was if they're both multiples of if it's a multiple of 2 and n. So I'm
Mm,
just basically making a number plus one every
hmm
integer and checking if both divided by if both are divisible without leaving a remainder. If both
hmm
are divisible without leaving a remainder, then it's true that both are multiples of each other.
Yeah, I mean that works, but it definitely is a little bit more confusing because you're taking like way more different steps. You're adding an extra variable. You're doing a while loop. It can become a little bit more confusing. For things like Leetcode, it's better to just do things as simple as possible. So even in C++, you can just you can solve this whole thing with just an if or an else statement without having to use a while loop, without having to add a new variable I. Um,
Yeah, yeah.
and yeah. All right. So moving on to two sum. So two sum is a very, very, very fundamental problem. So here's a question. Given an array of integer nums, right, and an integer target, return indices of the two numbers such that they add up to target. That's a lot of words and lots of numbers and math, and that makes no sense. But LeetCode gives you examples. So over here, it says you have an array nums, right? 2, 7, 11, 15. Your target is 9. Your output is 0 and 1. Because the first number, so index 0 and index 1, 2 plus 7 equals 9. Right? Let's go to the whiteboard and let's talk this out. We're going to go over two different solutions for this one. So two sum, right? Let's look at the, so I'm pulling it up on my other computer so I can find the examples. All right, so two sum. So given an array nums, right? Find two numbers in nums which are guaranteed. So it says there are at least there's exactly one solution. One solution that add up to target. And you're returning the indices of the array. All right, does everyone understand the question? Anyone have any questions about the question? No? Okay, so this is our question. So here is an example that they gave us. So here's the array nums, and in the array, you have the numbers 2, 7, 11, 15. Okay? And your target equals 9. So we have to find two numbers in this array over here that add up exactly to 9. So what numbers are they? Can someone tell me in this array?
2 and 7.
2 and 7, right. So always remember, when we're looking at arrays, we are always indexing based off 0. So position 0 has number 2, position 1 has number 7, position 2 has 11, position 3 has 15. So what should we be returning? Should be position 0, position 1. This is our return statement. Does that all make sense how we're finding the solution and how we came up with this idea? Any questions on that? No? Okay. So how would we actually solve this algorithmically? How can we use code to find this? Because I just looked and I saw, hey, 2 plus 7, that equals 9, and I found that as a target. So there are many different approaches you can do. In code, here's the this is what we call the naive or brute force version. So say we want to iterate through this array, right? Here's this array. We want to go through this array and compare each number with all the other numbers. So for example, if we're in 2, right? I want to compare it with 7, with 11, with 15. Pretend that 7's like 7 somewhere that doesn't really work out. So we're going to compare with that. We find the answer. If we don't find the answer, let's try with 7. We're going to instead compare 7 with 11 with 15. If that doesn't work, all right, let's move to 11, compare it with 15. Does that all make sense? This is sort of like the brute force of how we're trying to compare every single number to find out if we can find that one pair. So in code, this is how we do it. So I'm going to do sort of, I guess I'll do C++, or sort of C++, Python-y, whatever, for you guys to understand. So we can kind of go like this. We have an iterator, right, starting from 0. We can go until the I guess it's size, right? So we're iterating through this one time, right? We're going to count once. Let me erase this. We're going through this loop once, and now we have to compare it. So for each number that we have in this array, we want to compare it with every other number. Does that make sense? For each number in this array, we compare with every other number. That means we would have a second for loop. We can call it j. And this would be, I think, j equals I plus 1, more efficient. J less than this length of the array, j plus plus, right? So now we have two different for loops. The first for loop, again, just to visualize it, 2, 7, 11, 15. The first for loop is giving us the first number. Second for loop is comparing this number with every number. Then once j is done going through this one, right? Then it's going to go, I is going to go up 1. So now I 0, now I is 1. And then j is going to compare with the rest again, and so on. This, let's code it up. So here is 2sum, and we're going to try coding up what we just drew out. This is going to be a pretty slow solution, but it kind of works. So I'm going to use Python, again, just because I'm more used to it. What we're doing is that we're going throughout, we're just doing a for loop, the same that we showed over there. We're going to go through a for loop, then do another for loop. If nums I plus nums j equals target, return I, j. So this is the code that we have so far for 2sum. Pretty much what we're saying is we're going through the array n squared times, because we have nested for loops, and we're just going to return it. So let's try running it. Does this work? Oh, it works. First try. Great. So if I submit it though, here's a problem. Look at this runtime. 2,508 milliseconds. Now imagine if you had a huge data set. This would take absolutely forever. So this is what we call a naive solution. We're brute forcing it. Why are we brute forcing it? Because we're literally comparing like each number with every other number. This is really inefficient, and we're technically doing this n squared times. So this would be big O of n squared. All right. Any questions on the brute force solution for 2-sum so far? We're just comparing each number with each number, and if it adds up to a target, we're done. Any questions so far? Nope. All right. So then moving back to my iPad. Lots of you, by the way, gave me this exact solution in C++. So from the people who did 2-sum, this was the solution that I saw from absolutely everyone who submitted it, which is it works, right? Whenever you're solving for coding interviews and you're doing problems in HackerRank or CodeSignal, as long as it works, you already get more credit than if you try coming up with an efficient solution. You really want to try to get as efficient as possible after you solve it brute force. All right, so let's try finding a different way of doing this. So right now, what we've been doing is we've been iterating through the array multiple times, n² times, which means you're literally comparing every single number with every single number. But you don't have to do that. Instead, you can use a different data structure. It's called a dictionary in Python or a hash map in C++, Java, everything else. And just to give you a quick summary of what it is, it's pretty much a key, it's like a dictionary. You have a key, right? And it has a value. So we're going to use this key value idea to make something more efficient, because when something that you will learn in data structures is that reading through a hash map is O of 1. And again, this is a little bit beyond the scope of what we're doing, but just know that reading from a hash map is O of 1. So it doesn't take any time at all. It's very efficient. We don't have to even think about doing extra stuff. So what we can do is, if we have this array again, what was it, like 2, 7, 11, 13, and target equals 9. What we can do is we can actually utilize our data structures to our advantage. So we can create this hash map. Let's call this hash map answers, right? And what we're going to do is we're going to iterate. We're going to go through this entire array once, and we'll be able to solve the entire problem. So what we're going to do is we're going to create a hash map. The key of the hash map is going to be the actual number that we have over here. So for example, key would be 2, and the value will be the index, because here's the index, 3, 4, the key is a number, right? So if we do that for every single thing, we're gonna have something like this. And then the last one is just 13. All we're doing is we're adding this array that we just had, we're adding it to the hash map. So here's where we can really just use this and there's this kind of like magic, the way we work with this, but we can actually compare with the hash map to come up with a much more efficient algorithm. So what we're going to do is, instead, we're going to iterate through this array. We're going to go through this array once, and every time that we go in this array, we are going to we're going to check for the difference. So say a target is 9. Target is 9. And say we're at I equals 0. At 0, the number is 2, right? Because here's 0, here's number 2. So 9 minus 2 equals 7. That's the difference, all right? So now we're going to check, is the difference in this hash map that we added. If it is, you can just return the value of the hash map and your I. Or else add it to your hash map. It's going to make more sense when we actually code it out. So then, or else we can just add to hash map. What that looks like in code is will make a little bit more sense. So here we go. We're going to use a hash map. It's called, let's call it previous map. All right. Here we go. Now we're going to go through the array once. I can't spell in. All right, so in this one iteration, let's find a difference. Difference that we just talked about is the target minus, what's it called? Nums I. So what we're doing is we're subtracting the target number minus the current number that we're in the array. Then, if this difference it is in the previous map, return previous map, and then we're going to just use the key. So we're going to check for the key difference and I. And then we're going to add it to the previous map. So what we're doing is, first we're just checking the difference, right? Is this the difference, which is target minus the current number in the hash map? Then we're going to return that, or else we're just going to add it to the hash map. Whoops, previous map. And if we run this, oh, hold on, what did I do? Oh, did I forget the previous map? One sec, what did I, let me look up. Brief map, return. One sec, guys. Let me pull up my old solution. Or can Tim look at this and tell me what I'm doing wrong while I look it up? I give you 1 sec.
You have to do pref map I equals nums I think, right?
Right. Try this. Yeah, there we go. You're right. There we go. All right. So when I submit this version, we went through the array once, and look at this. Runtime is 61 milliseconds versus 2,598. So what we did was we used a hash map to our advantage. And again, if you haven't learned what this are yet, I just recommend for now just try following along and looking at the different ways of solving these problems. All right. Any questions on two sum? No questions on two sum? All right, moving on. Two sum two. So this is a very similar problem. You can literally copy and paste the solution, and I'm pretty sure it works. Oh, well, this just says numbers instead. But I'm going to read the question. You're going to see it's actually very different. Oh, plus one. Whoops. So we can literally copy and paste. Oh, what are you doing? Whatever. Anyways, right before it. Either way, 2 sum 2 is exactly the same as the original question. Given a one index array, which is kind of the difference over here, that is already sorted in non-decreasing order, find two numbers such that they add up to a specific target number. So what we're doing is we're finding, again, two different numbers that add up to a specific target. And it's, again, same exact problem. Numbers 2, 7, 11, 15, target equals 9. And we're outputting 2 and 7, which for some reason is indexed by 1 rather than 0. So it's exactly the same thing as 2 sum, but it's sorted. What does it mean when an array is sorted? Does anyone know what that means in terms of the array? What is on the left and what is on the right? Fred, I'm going to ask you. Fred, what happens when an array is sorted?
Number is on the left
Right.
and the highest number is on the right.
Exactly. Thank you, Fred. So when you have an array, the lowest numbers are on the left and the highest are on the right. Right? This is a sorted array. Right? This is not a sorted array. So to solve two sum, we're going through the array We're comparing each number to each other one by one. And then afterwards, we use the hash map. The difference now is that using a hash map takes up memory on the computer. And 2sum2, actually, the whole point of 2sum2 is it says you're not allowed to use any extra memory. So what that means is you cannot make a new data structure. You have to somehow find out the answer without making a hash map or making a new array. So how can we do that? So here is where we came up with two different solutions that, if you all know something about this guy named Clint Weiswood, who, if you have taken 320, you know he's an absolute legend. There are many different ways that we can solve this problem. So we know that there is a solution in this array. So if the answer was 2, 7, 11, 13, and the target is 9, we can come up with this in two different ways. This is what Clint came up with, and I think it was actually pretty genius. It wasn't the most efficient solution, but it was pretty genius. So say we have a for loop, right? And we're going through this array once. What we're going to do is that since we know that the answer is in the array, why don't we just search the array? Why don't we use binary search? Because why not? Because Clint is an absolute genius. Why don't we just search the array? So if we're in I over here, why don't we use binary search to find if we have the difference, which is target minus nums I, right? So we're going to go through the array once, and then we're going to search is 7 over here. Yes, it is. And that was his solution. I thought that was pretty genius, but it actually is pretty inefficient because it's actually n log n. Reason why is because we're going through the array once, and then binary search is just log n. You're going to learn about this in algorithms class. Another way that you can solve this problem is using something called two pointers. So this is going to be a very basic algorithm they're going to be using in Leetcode for arrays, especially when they're sorted, is to use an idea called two pointers. What that means is you're going to have two different variables. You're going to call them left, and the other one's going to be called right. And we're going to set these to 0 and to the last number index, which would be something like length of nums minus 1, something like that. Okay? So here's what they're going to look like. Here's your left, and here's your right. Okay? When we're looking through this array, target is 9. All right. Is and yes, so sorry, in this tab 2 plus, we're gonna have to find the sum. So does 2 plus 13 equals 9? No. That's 15. Is 15 greater or less than 9? Can someone tell me?
Greater.
It's greater. Right. So what's like the secret behind sorted arrays? What happens as we go from left to right? What happens to the numbers? Do they go up or down? They go up. And then if we go from the right, they go down. So right now, we're making a big window. We're looking at the first and last. 2 plus 15, 13 is 15. We're trying to find 9. So it's too big. What we're going to do then is we're going to erase this pointer, and we're going to move one down to the right. Because now we're making this smaller. So now we're going to go down. Is 2 plus 11, that's 13, greater than 9 still? Yes. So what should we do next with our pointers?
You still move the right one left.
Exactly. That's correct. So now we're here. All right. 2 plus 7. Is that 9? Yes. Do we find a solution? Yes, that's the solution. So this is called the two pointers method. What we're doing is we're using two pointers, and we're kind of thinking, is the sum of these two pointers bigger than the target? If it is bigger, let's make that sum smaller by moving the right pointer, right, this pointer right here, to the left to make it a little bit smaller since we're talking about a sorted array. Now this method only works when we have a sorted array, because if it's not sorted, it's just there, you won't know if it's bigger or smaller by moving left or right with the pointers. All right? So does everyone understand how to do this two-pointer approach? Again, we're finding two different pointers for two variables. Left equals 0. Right equals the the last number. And we're just comparing these two sums. So if it's too big, we move the right pointer. If it's too small, we move the left pointer. Any questions on that so far? No? All right, then let's try coding up these two solutions that we came up with. So let's start just real quick with binary search, just because I thought that was pretty smart by our man Clint Wiswood. Again, if you guys haven't taken 320, you should definitely go to your Branix server and watch his videos because they're absolutely insane. All right, so let's try doing this now first with binary search. So we're going to create just an n equals length numbers. If n equals 2, return 1, 2. What we're just doing is just like a base case that we had. This is what Clint came up with. Actually, hold on. I have a better one. Go. Hold on a second. I'm just trying to pull up all my old solutions so I make sure I don't give you guys the wrong thing. Oh, there we go. So yeah, never mind. Clint solution is weird. All right, so let's go through this array. For our in range, len numbers. So what we're doing here is we're going to go iterate through the entire array once. Okay? And now we're going to set up some variables for binary search. If you haven't learned binary search, here's your chance. So what we're going to do is we're going to go through the array, right? So we're iterating through the array and we're trying to find to see if there is a second number that adds up to the goal. So we're going through each number, searching the array, finding its counterpart. If it doesn't exist, then we just keep going. So in the end, this is just binary search. I'm just going to give it to you. So right now we're here setting up the variables, low, high, and then pretty much just giving you what's going on. And then goal equals target minus numbers I. So what we're just saying is we're finding a difference, right? Difference is target minus numbers I. And now here's this binary search. Well, low is less than high. We're going to find a midpoint. And then again, you're going to learn this in data structures algorithms. You should memorize binary search eventually. It's pretty important, pretty quickly to implement. So I'm going to share this, just give it to you. So pretty much if the number that we're finding is greater than the midpoint, then we're going to set the low to mid plus 1. Else if the goal is less than numbers mid, high is going to be mid minus 1. This is just a flat out just implementing binary search. Again, you're going to learn it's not good, so don't worry too much about it. So if you run it, it works. The way this works again is we're kind of just searching, we're finding the first number, searching through it, and going for it. However, if you look at the runtime, it's 160 milliseconds. It's a little slow. So now let's try doing a 2-pointer approach that we talked about. Because this is going to go for 3-sum as well. So here's a 2-pointer approach. Again, we talked about how we're going to have two different variables, right, left equals 0, right equals the last number. And let's just set up sum so it's ready to go. All right, left pointer, right pointer, and just the sum. And now we talked about we're going to go through this, and while left is less than right, so we're going to, until they meet at the middle, we should keep going. The sum is equal to just the two different ones, numbers left plus numbers right. Just like in the drawing that we talked about, we're adding these two numbers together. And then so let me just write that down. So while we iterate through the array once, if the sum that we come up with is greater than the target, so if 2 plus 13 is bigger than 9, like we talked about before, then we should move the right pointer left by 1. So I'll just give you another comment. If the sum of left and right pointers greater than what we need to add, sum2, move right pointer 1 to the left. All right. Or else, if that doesn't work and the sum is less than the target, let's move the left pointer to the right. So if sum is smaller than target, i.e. 2 plus 5 is less than 9, right? Move left pointer to the right to make sum bigger. And then if the sum is equal to the target, we found it, we got the answer. So let's just return. And again, it makes you add 1 for some reason, but you can just return left and right normally. All right, so we run this, it works. And we submit this, runtime is a lot faster than 160 milliseconds. And again, runtime's a little bit weird because it gets faster, it's slower if you just submit it, so don't worry too much about it. As long as you're efficient, it should be pretty good. All right, does anyone have questions on the 2 pointers approach that we did for 2sum? Any questions? We just to reiterate, we go through an array once, we look at the left and the rightmost digits, and since it's sorted, left is smaller, right is bigger, we're just going through there and seeing if it adds up together. So this is the efficient solution. This would be big O of n, because we only go through the array once. Any questions? All right.
My solution.
I still have a question. Or did you just unmute by accident?
That was me. I said my solution.
Oh, thanks, Justin. Sorry, well, you guys should definitely go to my Leetcode workshop if you aren't really too sure what's going on, because I'm just trying to give the solutions right now. So I'm kind of expecting that if you know about hash maps and these things, they should make sense. But definitely, if you are really confused right now and you don't know what's going on and you're just trying to follow along, first of all, don't worry, because I also knew nothing about what's going on until I watched like 100 hours of Leetcode videos and solved like 50 Leetcode problems. For now, just try following along the best you can. And if you have time, you can always come to our future workshop for Code for All, which is just talking about how to actually solve these problems and from a very fundamental basis. All right, so 3sum. Given an integer array of nums, we're returning the triplets that add up to 0. This is practically the same thing as 2sum. The target this time is going to be 0. And we're trying to find 3 numbers that add up to 0. There will be more, 1, but cannot contain duplicate triplicates. All right, so 3sum is a little bit more advanced because now we're having 3 different numbers add up and the target is 0. So this is the exact same thing as 2sum 2, but just a little bit more. So let's go back to the whiteboard. All right. So this problem, it's asking find all triplets. So like pairs of 3, for example, 0, 1, 2, that add up to 0. That's pretty much just asking you. Find all sets of 3 numbers that add up to 0, cannot be duplicates. For example, the answer 3, 6, 7 cannot be written twice. Does everyone understand the question that we're trying to solve? We're trying to solve 3 and 3. We're trying to find all the triplets that add up to 0 in the array. Any questions about the question? No? All right. So here is going to be an example that they gave us. So here's nums. It's going to be -1, 0, 1, 2, -1, -4. This is the example that they gave us on Leetcode. And then our output should be -1, -1, 2, -1, 0, 1. Why? Because, again, let me add the indices, 0, 1, 2, 3, 4, 5. Why? Because numbers, this is 0, right? -1 plus 0 plus 1 equals 0, right? Indices 0, 1, 2 equals 0. So we're going to add that here. See? -1, 0, 1. This is a solution. We added that there. Okay? Here's the second solution. -1, -1, and 2. Where do we find that? Let me erase the first solution. We found it over here. -1, and over here. -1, 2. So -1 plus 2 minus 1 plus -1 equals 0, right? That's another thing that adds up to 0. We added it to our output. So right now, we're just kind of looking at the problem. We're just looking and trying to find these things. But how do we actually do it on a computer using code? So I'm going to go through the brute force solution, and I'm going to give you the actual efficient solution, which is going to be the exact same thing as 2 sum 2, but just a little bit different. So what we could do, which is a pretty obvious solution, is what if we start from, we have 3 pointers, I, J, and K, right? What if, here's I, we go and say here's J, and what if, let me add a different color, we compare K with each number over here, right? Do any of these add up to 0? Oh wait, we found it here. 1, 2, 3. Brute force. What this would mean is we're literally iterating through every single checking it with every single other number, and until we come up with a solution. So just to give you an example in code, this is something that you're gonna do in 211 with Waxman, which is like, I think he calls it like dumb 8 queens, which is where you use a ton of for loops just to solve everything. So here we go. Let's do it. Let's just brute force it. So here's a first for loop. And then we have 3 pointers. We have 3 different numbers. So let's do another for loop. Why not? And let's start from I plus 1, because we don't have to search before I. We don't want to have duplicates. Length of numbers. And then wait, we need a third point. Let's do another one. For K in range. And again, just J plus 1. Length of numbers. Alright. I think that's enough for loops, right? Oh yeah, let me add a results answer. We're going to make a set. Again, if you haven't learned about sets are like lists or arrays, but sets actually can't let you have duplicate numbers. So over here in the question, it says it cannot contain duplicate triplets. So just as a precaution, I'm going to just use a set. Because in Python, a set, for example, if you have 0, 0, 1, 2 in your array, the set would end up being 0, 1, 2, because it deletes the duplicates. So that's kind of just guaranteeing that we don't have any duplicates. Okay? Alright, so now we have our 3 for loops. We're looking through every single number. Let's compare it. Nums I plus nums j plus nums k equals 0. We're just kind of adding all of them together, brute forcing it. Then here's a little bit of magic. We're going to actually have to sort it. So here's a triplet, because we want to make sure it's unique. Again, don't worry too much about the data structures I'm using, but we're going to use a tuple, and we're going to sort for now, don't worry about the implementation. Think about just the way we're thinking about solving this algorithm, because this is more just advanced Python stuff. Nums j, nums k. This is absolutely disgusting. Result, and we're gonna add this triplet. And then I think if we do this, and we turn it back into a list, I think it should work, right? Yes, it works. Cool. So what we did is we literally went through every single number. We compared it with every single number 3 times. And if those 3 numbers add up to 0, we just did some Python magic to make sure that there aren't no duplicates. And we added to our list of triplets. So we have 3 different for loops. This is a big O of n cubed. This is gross. And look what happens if we submit this problem on Leetcode. First of all, it takes forever. And then watch what happens. And again, I have Leetcode Premium, so it actually gives me faster. Oh, there we go. Time limit exceeded. I literally couldn't. It took so much time that I couldn't actually finish this problem. So if I look over here, this is like the list that they gave us. It's a freaking monstrous list. And it's not even that big in the grand scheme of things. And my code was too slow for it to work. So by doing this, it's very inefficient. So let's just scrap this. This kind of sucks. And let's go back to the whiteboard. All right. So that kind of sucked. What we did is we literally went through each one n cube times, and that just took forever. Let's be a little bit more smart about how we do these things. So here's our list again. I'm just going to erase all the work that we did. And I'll keep the output. Okay. So another way of doing this is, again, just using the 2 pointers. But wait, you might ask. We have 3 numbers. So how do we do 2 pointers? Well, we're actually kind of using 3 pointers, but it's sort of 2 pointers. So what we're going to do is we're going to go through this array once, just once, with say I, right? I is going to go through each number, same as before. We're going to go through the array once. And for each I, we are going to have to do another loop where we have 2 pointers. So at this point, we've solved the first pointer. It's just going to be I is just going to be going in a for loop throughout the entire array. And then what do we do for 2 sum 2? We use 2 pointers. So here's going to be J. And here's going to be K. Or actually, let me just do left and right because it makes more sense. So here's left. And then right. Okay. So now we have I. So it's going to be -1 plus left pointer. We're going to be going to negative plus 0 is -1. -1 is, and then if -4, that's too low, we're going to move it to the right until we find 1. Same exact concept. We're going to be comparing these 2 pointers and trying to find out if it adds up together. So the actual logic that we're thinking when we're solving this is while our left, right, is less than our right pointer. So while these 2 pointers don't intersect, and they're still, like, they're not, like, both over here, right? While they don't intersect, the sum that we have right now, right, is going to be the left pointer plus the right. It's gonna all stuck there. Oh, I can move. Nice. All right. So again, oh, hold on 1 second. Plus nums I, right? So we're adding these 3 together. All right. If the sum is greater than 0, right? The sum is greater than 0. Then move the right pointer leftwards to remove the sum. Right pointer left to increase sum. Oh, sorry, I completely forgot. Really important, really important fact. You're supposed to sort this. My bad. So let me quickly fix that. So again, 2 pointers only works if you sort things. So once we sort it, right, you had -1, 0, 1, 2, -1, -4. Let's sort that again, which would be -4, -1, 0, sorry, -1, 0, 1, 2. There we go. This array is sorted. So again, sorry, you have to sort this. You can use, I'll explain that later. But you sort it, and again, we have the right. If the sum is greater than 0, you move the right pointer, right? Because again, bigger numbers are on the right, smaller numbers are on the left. You move it down. If sum less than 0, right? That means too small. Then you're going to move the left pointer. Right? So this pointer over here, left, moves to the right. Same exact process as before. We're comparing, on the right side of the array is bigger, left side of the array is smaller. As we move to the right, the number gets bigger. As we move to the left, the number gets smaller. All right, once we find the actual target, we want to add it, just add it to our list. All right, and then afterwards, just move our pointers and continue. So let me just show you guys this in code, because it'll make a little bit more sense over there. All right, back to 3-sum. Okay, so we're going to make a list. List to store resulting answers. That's right. So let's call it results. So like I mentioned before, I totally forgot to mention this, but you can't do 2 pointers if it's not sorted, so let's just quickly sort it. Nums.sort. Well, all we're doing is we're sorting the numbers list, so the 2-pointer technique is able to be used, right? So low to high in the array. And then we're just going to iterate. Now we iterate to find the first of 3 triplets I. And here we're going to go for, and I'm going to just use this because it's a little bit simpler. We're going to just use enumerate. All this does is it just splits up the answer with into 2 different variables. So like I, if a is greater than 0, break, right? Because if the current number is positive, break, because there is no triplet. That can sum up. What that's saying is that if we are going to an array, right? And if our first pointer is, so here's like -4, -2, 0, 1, 2, 3, right? Here's a sorted array, right? And say our pointer is here, is pointing at, say, 1. Is there any number that, any 3 numbers that can add up to 0? No, because it's all going to be positive, so it's going to be sorted. So we're going to break and just not even bother looking at this. All right. And then we're going to also skip duplicates. So we prevent duplicate triplets. what we're going to be doing here is, say, for example, we have an array and it's -2, -2, -1, 0, 1, 2, right? You would have two answers, which is -2 and 2, -2 and 2, but they're duplicates. So we have to make sure we skip the second 2 over here. So but to do that, all we have to do is just say if I is greater than 0 and a is equal to nums I minus 1. So what we're just saying is if we are at least in the second number of this array, right, and the current number that we're at, the current nums I is equal to nums I minus 1, so is the number same as the previous number, right, then just continue, skip, move on. All right. So what we're doing right now, just to again remind you what we're doing, we sorted the array, and we're going to try to find I. All right. Now we're done with all the crazy stuff. Let's start actually doing our 2-pointer technique. So pretty much it's going to be, we have left, right. Let's do left equals I plus 1. So right equals the last number. Again, first number after I, last number of the list. And again, we talked about before, 2 pointers, while, left, less than right, same exact thing as 2 sum 2. Let's calculate the sum, right, which is going to be, let's call it 3 sum, equals a plus nums, nums left plus nums right. If, so here's the sum, if the sum is greater than 0, move the right pointer left. So if 3 sum is greater than 0, right moves left. If the sum is less than 0, move left pointer right. So else if 3 sum is less than 0, move the left pointer. Oopsie, right. Or else we found the answer. So, or else we found the answer. Sum is equal to 0. So let's add it. So we're adding just the triplet. All I'm doing is just this nums left, nums right. All right, and now we're just going to move our pointers one up, just so we don't accidentally duplicate anything. So what we're just going to do is just going to go left. We're going to move that one up, and right, move that one to the left. Okay, so again, this is the exact same thing. We have 2 pointers, right? We're calculating the sum. If it's bigger, then we move our right pointer to the left. If it's smaller, left pointer to the right. Or else we found a number, and then we're just going to move the pointers just to avoid duplicates. And then we're going to do some more duplicate stuff. Just make sure you skip the same number, duplicates for the left pointer. This is just extra stuff that I realized when I was solving this. You're gonna have lots of duplicates. So just while numbers left equals numbers left minus 1. So we're just comparing, right? If the current number we're at is equal to the number before it, that's a duplicate, and left is less than right. Left, we move left one more. And then I think that should be it, right? Return results. See if that works. Ah, what did I do wrong? Did I just move it out the loop? Maybe it goes over here. There we go. And we submitted it. And here we go. We just beat 91% of users with Python 3. So, oh, where'd it go? My solutions disappeared. Ah. So what we just came up with was we taught you guys how to use a two-pointer solution. So this is something that if hopefully the two-pointer solution made a little sense for you, I recommend you practice it. It's going to come up a lot. So the way that you would practice it, and again, this is the other solution that we came up with, is you go into Leetcode, you look in problems, and you can literally look up two pointers. And all of these problems are two-pointed problems. Code.io, this guy has like a roadmap, and he's a really good teacher. So if you click on this, he has different techniques that you're going to be learning. Here we just did two pointers, and hey, look, we found two sum 2, two sum 3. He's awesome. If you don't understand what I just taught you, I recommend you watch Leetcode because he's such a better teacher. He's amazing. I swear by him. He has YouTube videos on every single topic. He's going to go over the exact same thing that we just talked about in a very elegant way, and he's going to code it up the same way that we just did. All right. Does anyone have any questions about today's Leetcode problems?
Yeah, I'm a little bit confused with the threesome solution for that. What is A again? And for that for loop, where is it pointing to when we first initialize it?
Okay, so what I just did was, this is a more of a, like, I can also do this in this way. Find range. What did I do? Find range. So what we're doing is that instead of doing something like nums I, right? What we do in enumerate is just we're just splitting it up. So it's the same exact thing as like saying nums I, but we're just saying I. You're calling it A, and so it's just a little simpler. So nums I is the same thing as just calling it A. So we're just giving A a variable. Does that make sense? Nums I?
Yes.
Yeah, so I just call it A just because why not? But for the first for loop, your question was like, what are you doing? For the first for loop is just going through the loop once. So like we talked about in the drawing, right, we were going through the sorted array, and I'll call this A, so it makes a little bit more sense. So here's A, right? And when we're at A, we're comparing left, right, and we're doing all of the two pointers things going over here, right? We're doing all of this math, and A still stays here. So A stays here, and we're doing all of this the whole time until we find a solution. If we don't find a solution, then we just move A one to the right. And now A is pointing over here. And again, we're doing two pointers, so left would be here. Right would be here. And we're just, again, testing, is it bigger, is it smaller? Move our pointers accordingly, and so on. So A is going through the array one entire time, right? And we're doing two pointers for every single number after A. Does that make sense?
Okay, so left and right both have to be after A.
Yes. A is sort of like because you were here for two sum 2, right? Two sum 2 is exactly the same thing.
Right.
What we're just doing is we're doing two sum 2 that we just did in the first problem, which is literally just comparing left and right, but we're just adding an extra number just before it. But we could ignore A. Once we set up the for loop that we did, we can just forget about this. And this is exactly the same thing where we just pretend that A is the first number, and then we're going to compare the numbers after A by using two pointers. And then A is going to move one up, and the same process continues. Does that make sense?
Yeah, thank you.
Cool. Any other questions? Are you guys scared yet? All right, so hopefully for those of you who stuck here who are freshmen and you are literally doing some Leetcode mediums right now, which are given to people who are looking for actual full-time jobs, props to you for sticking around because this is a lot. If you really felt like you were lost, which I'm sure many of you were because you don't learn this in school, you have to kind of just grind this out. It's very, very different from when you learn class. I really recommend you give this a shot. It's not as crazy as it might seem from the beginning. They're just practically brain teasers. Like I said, I really recommend you go on Leetcode.io and just start from the beginning. He has like super basic stuff, and he gives you coding solutions in like all of these different languages: Java, C++, TypeScript, JavaScript, whatever you want. And he has some really cool videos that go over this. Something that you could do is you can just go on Leetcode.io, go onto each of these topics, right? 2-pointers. If you want to learn more about 2-pointers, because there's lots of questions on 2-pointers, you can go on YouTube and watch different tutorials on just how to solve, like how to understand this algorithm. And this is the exact same thing: valid palindrome, 2-sum 2, 3-sum. They're all the same pattern. All we're doing is we're comparing a left and a right pointer. If it's bigger, right, we move the left pointer to the left. If it's smaller, we move the right pointer to the right. All of these problems are the exact same thing. And that's sort of like the point that we're trying to drive home today, is that these are all the exact same thing. We're comparing two different things. Like here, we did the same exact thing. It's patterns. You're learning these patterns of how to solve these problems. And once they kind of come up in your head and you kind of understand them, you'll be able to implement them. Leetcode's really helpful because he orders it by different ideas. It's somewhere over here. But he has this, or I guess he sorted it now before in the roadmap. But you have so many different versions of these algorithms. Sliding window is just 2-pointers, but like different. Binary search, we went over that. Like there's so many. These are all the same exact thing. This is like literally implementing binary search. And then the next one is like searching a 2D matrix, which is, again, you're using binary search. All of these are just binary search. Once you understand binary search, you implement the exact same algorithm, which is slightly different tweaks, and you get the answer. So with 2-sum that we just did, 2-sum 2 input array is sorted, right? If you look at the code that we just did, right? While left is less than right, sum equals numbers. If sum is greater than target, move to right. Or sum is less than target, move to left, or else return these two, right? 3-sum is literally the exact same thing that we just did, right? While left is less than right, calculate the sum. If the sum is greater than 0, move to right. If the sum is less than 0, move to left. Or else, this is the solution. Plus some extra little logic to make sure that we don't get any duplicates, right? Is the exact same thing. And I know it might not seem like it at first when you look at these problems, but the really important thing to drive home is that it is the exact same thing once you understand these patterns. So your goal is to just start, because Leetcode isn't that hard at the beginning. You can sort by difficulty. There's some really, really easy ones that you can do that are just that, like, if you look over here, they have acceptance rate, right? The higher the acceptance rate, the easier it probably is. So once you understand, like, once you look at these high acceptance rates, try just solving them. It's like here's one that you can do, right? One, if say you can't find a solution, you're confused. Give it like 15 minutes. Read the question, talk it out to yourself, draw it out on like a piece of paper, try to reason out the algorithm, and try to understand it just on a fundamental level, just as a human would solve it. If you still can't solve it after 15 minutes, there is an editorial that you can look at, and over here it has solutions. And it gives you code in C++, Java, and also over here there's solutions that you can look at that people did. Or my favorite, just look at Leetcode, because Leetcode literally has almost every single Leetcode problem, and he will give it to you both in code that is usually better than whatever they give you, and he literally draws it out for you. So you have, it's just like, the guy's just beautiful. He's just great. He's the best. So watch his videos. If you can't solve a problem, look at his like drawing solution, and then just pause it. So once you kind of saw how he reasoned out with his 2-pointers idea that he didn't 2-sum, then just stop right here. Don't look at his code. Try solving what he just did in pseudocode and drawing it out. And if you still can't get it to run, then look at his code and try understanding it. That should be your strategy for solving these Leetcode problems. And it's really, really important, again, that you go through these, because this is what's going to get you jobs. This is my first time explaining Leetcode to people, so it was good practice for me, because you're going to have to be able to explain your thought process to these recruiters. You're going to be on a one-to-one call with someone. They're going to give you something like 2-sum or 2-sum 2, and they're going to say, all right, solve it. And you need to talk to them and tell them exactly what your thought process is. You're supposed to draw it out. You're supposed to explain what we're doing and trying to reason towards a solution. So it's really, really important that you guys give this a shot. Do all the easy ones. The easy ones, I promise, aren't that hard. Go by topic. Start with arrays, start with 2-pointers, sliding windows. This is the same exact thing. Once you feel a little brave, try learning about stacks. It's just an array, but like you're pushing and popping only from one line. You learn about linked lists in 212, I think. So once you learn about what a linked list is, here's like 20 problems you can do with linked lists, and they're all very similar. All right. So this is just my advice for Leetcode. Give it a shot. If you're new, just try the easy ones. Look at Leetcode, look at the solutions, watch the videos. If you still have questions, I'm always open to helping whenever I can, or ask anyone else who's really good at Leetcode in this group. Like I know Shigu and Fred are really, really good. I know Ramel's also really good at this type of stuff. So you're always welcome to ask on the Leetcode channel on the Discord. But I really recommend you look at Leetcode, and it's free. You don't have to pay. It's absolutely free. I paid because he has lots of courses that are just awesome. Like his data structures is literally 313, but better. Advanced algorithm is literally 323, but better. So I mean, if you want to pay for it, you can, but you don't have to pay for it. There's so much free stuff. All right. Does anyone have any final questions before we end the session for today? No? Last chance?
Wait, my bad. I couldn't unmute my mic.
Yeah.
Do you know when the next session will be?
We're gonna do Leetcode Fridays every Friday. It probably won't be as long as this one. I just wanted to give you guys like just an overview of how to solve problems in general. Afterwards, what we're gonna be doing is probably you're gonna submit your answers. I'm just gonna go over the optimal solution really quick, show you what it is, and hopefully, whoever has the most optimal solution will give them the role of Leetcode winners. Don't worry too much about what the runtime says. I just want to make sure you can kind of analyze it. So we talked about, for example, threesome. I can say, well, we are going through the array n times, and then in the array, n more times for 2 pointers. So it's big O of n squared, something like that. Like as long as you are able to explain this type of stuff, that's what we're looking for. Because C++ is way faster than Python, so it's not really fair to compare that. Any other questions? He has a really, I think this is a free course. Frontend Masters is an amazing website. This course is free, and also if you're a student, you can sign up for GitHub Student using your student email, and you have access to Frontend Masters for 6 months, which is like $100-$200, and it's completely free as a student. This course is really, really awesome. It's about 9 hours long, which if you think about it, is like maybe 4 weeks of like a regular class, and it goes over all you need to learn about data structures, algorithms, big O, like he goes over in like 10 minutes. Everything just, it's great. It's free. I'll share this link on the Discord as well. This is awesome resource for you guys to learn a little bit more about algorithms. I'll share this all on Discord. All right. Any last questions before we end this session for today?
I have a question.
Yes.
So, what time do you usually do these on Friday?
I think we're probably gonna do 7 p.m. just because I'm an old man, so my bedtime is tomorrow, so it's kind of past my bedtime. So
No problem.
probably around 7. I wake up at 6, so I usually sleep around like 9:30 or so. But this will be recorded, and again, this is a longer one because it's the first day, but these will be quick. Hopefully, by the time you guys get more comfortable, we'll have you guys discuss and explain this type of stuff. It's good practice because you have to be able to explain what you're doing in an interview to other people. Any more questions? All right. Well, if we have no more questions, that's about it for today.